All right, guys, Mr. Antonucci here, and we're back at looking at how to find the volume of a solid with known cross sections. So here, I'm going to show you one where we have a region R bounded by the graphs of F and G, and I'm going to show you how to do a mix of doing this in Desmos as well as things on paper. So the first thing we want to do is we want to graph the equations in Desmos. So we have our equations graphed here in Desmos. First thing we want to do is get the intersection points. So I'm going to put that one there, click on the dot, put it over there. And then instead of each of these, I'm going to use the x value, a equals 0.19502. And then this one, b equals the x value here, 4.96144. Now, I know all of the ones that we need to do here are going to be with respect to x, so I don't need to worry about getting the y value of the coordinate. No, this should be b equals. Okay, so we have the intersection points there. If you were showing work, what you would have to do is write f of x equals g of x, and then x equals a equals 0.19502, and x equals b equals 4.96144. So that's how you would show your work for that. Now, the first thing that we're asked to do, each cross-section perpendicular to the x-axis is a rectangle with height twice as great as the width in R. This is region R. The cross-section is perpendicular to the x-axis, and this is its base. And then we have a rectangle, rectangles being like stacked on top of that, where the height is equal to twice the base. So the area formula is just going to be base times height, where the base is from here to here. And if we do top minus bottom, that is just going to be g of x minus f of x. The height is twice the base, so that's going to be 2 times g of x minus f of x. Now, what this all simplifies down to is, notationally speaking, it would be 2 times g of x minus f of x quantity squared. The 2 would not be squared. So then to get the volume, we would do the integral from a to b of a of x dx. So this, we would call this a of x, and we would integrate the area formula. Now, to actually get the area, we could do int a to b of 2 times g of x minus f of x quantity squared. Make sure that 2 is not squared, just the g minus f dx, and you get 172.303. The next thing we want to do, each cross-section perpendicular to the x-axis is just a square with base in R. So same region, but this time, if we do a vertical slice, because it's perpendicular, we're just making a square. So the area of a square is just a side length squared. In this case, S would equal top minus bottom. This is the distance S here, which is going to be g of x minus f of x. So g of x minus f of x squared. If we name this the area function, then we can say the volume is equal to the integral from a to b of a of x dx. Okay, because I've already named what f and g, a and b, a of x are, I can just use those instead of writing out all the formulas and functions. So if we want to evaluate it, we just do the integral from a to b of g of x minus f of x quantity squared dx. and you get 86.15. The next one is each cross-section perpendicular to the x-axis is a square with diagonal in R. Okay, so they're getting fancy here. The distance is still g minus f, but you have to think of this as a square with the diagonal in the base. Now, if we isolate that square, I know the diagonal is right here. Okay, the area of a square is the side length squared. Okay, but if you take the diagonal, that's the dimension that we know. So we need to get the area of a square in terms of its diagonal. Well, if I isolate the 1/2 of that diamond, I would have this is the diagonal, and this is the side, and this is the side. Then we would get the area formula for that. And we can use the Pythagorean theorem because this is a square, and so this corner is a right angle. I know that d squared is equal to s squared plus s squared. So that means d squared is equal to 2s squared. S, if I just put it over here, is equal to d squared over 2 and the square root of that, which would be d over the square root of 2. The diagonal in this case is g of x minus f of x. The volume formula is going to be the integral from a to b of s squared. So s is d over root 2, d is g of x minus f of x over root 2, whole thing quantity squared. Now you could square the square root and just make it all divided by 2. Here's how we would set this up. Integral from a to b of, put our fraction in, the denominator is going to be square root 2. The numerator is g of x minus f of x. We're going to square that whole quantity, dx. The next one that we got 2 more that we're going to do in this video. Each cross-section perpendicular to the x-axis is an equilateral triangle with side in R. Do our representative slice, and it's going to be triangles. Well, the area of an equilateral triangle, remember each side is x, and this would be the height. Okay, so to get the area of the triangle, it's going to be 1/2 base times height. Now, if we isolate this triangle right here, this is h, this would be x over 2, and this would be x. So by the Pythagorean theorem, h equals the square root of x squared minus x squared over 4, which is square root of 3/4 x squared, which is x over 2 root 3. So the reason that is important is because x represents the distance here that's in between the two boundaries, G and F. So what this boils down to is that the area is 1/2 the base of this triangle, which is G of x minus f of x, times the height, which is G of x minus f of x over 2 times square root of 3. So we'll have integral from a to b of 1/2. Now I'm going to do g of x minus f of x quantity squared, because we have g of x minus f of x times itself here. Also, the 1/2 is going to multiply another 1/2, which gives us 1/4, and we're going to have a square root 3 there. Get our dx, we're going to get 37.305. Each cross-section perpendicular to the x-axis is a semicircle with diameter in R. We're going to have vertical slice, and it's going to be the top half of a circle. So if you can imagine a bunch of those, it's just going to get smaller and smaller. So the area of a semicircle is 1/2 pi r squared. Since the dimension that we're given is the diameter, this is going to be diameter over 2, and the diameter is the distance between G and F. Since G is on top, we'll do G of x minus f of x all over 2. So the area function is 1/2 pi times r squared, G of x minus f of x all over 2 quantity squared. Integral from a to b, 1/2 pi times G of x minus f of x all over 2 quantity squared dx. And we got our answer there. Okay, now this integral is what you would want to write down in terms of your work if you were asked to do this one. All right, guys, that's it for this video.